Hello guys, in this question we are going to look at an example of computing a confidence interval for the population proportion. We also need to check assumptions. Okay, so when you read the question about the population proportion, there should be two numbers. They're both integers, but one is larger than the other. And one of them will be the number of successes, and the other one would be the number of trials. So this is similar to binomial distribution. Now you need to remember that the number of successes is always less than the number of trials. So your x in this particular case would be 32, and n, which is the number of trials, would be 115. Okay, so the first thing I'm going to do is show you how to check assumptions. So let's open up Desmos calculator in a sidebar. And we're going to have two numbers, right? X divided by n. So x is 32. And then we divide that by 115. So this is called the point estimate. So what we just computed, let me add a note here. This is called the point estimate of the population proportion. Okay, so to compute this quantity, to check for assumptions, we need to compute n. Well, n is the bigger of the two numbers, so that would be 115, multiplied by p hat, which we just computed, and never convert to a decimal. So don't use this representation, use the actual fraction. Okay, so just like that, and then open parentheses 1 minus, and again copy paste the fraction from here. Do not convert it to a decimal because you could get in trouble with the rounding. At this point you can go ahead and round, so you can say round, click on the number and then comma 1. Okay, so that should be 23.1. That's the assumptions. Now on the test I will also say, okay, is that at least 10? And depending on, of course, what you get, you will say yes. If yes, then that means the assumptions are satisfied. And for example, if you got something like 8, which is not at least 10, you would say no, the assumptions are not satisfied because np hat 1 minus p hat is not greater than or equal to 10. Okay, so that's as far as checking assumptions. Let me go ahead and clear the calculator for now. Let's now turn to the computation of a confidence interval. So what do we do for that? Well, we click on the plus sign. We're going to go to inference, right, which is the familiar menu. From here, you're going to go to the z-test for proportions. Okay, so you click on that. It'll ask you what's the number of successes. That's 60, oh, I'm sorry, 32, and the sample size is 115. Okay, now if you mix them up, Desmos will complain. Like if you by accident put 115 here and 32 here, Desmos is going to say something's wrong and you can't even create a test, which is great because that's a check to understand what's what here. Okay, so once we put that in, we're going to click on create test. And at this point, we expand the confidence interval menu, and we already have a confidence interval, but it's not going to be 95%. Well, right here is 95, but we need 94. So we're going to have to click in the box, and we have to put 0.94, right? We can't put 94. Desmos will not understand it. It'll be undefined. Okay, so that's the interval. Now, I definitely need to round more because it does not show me enough decimals and I need 4. Okay, so under the 3 dots, right? You can see the 3 dots right there. I'm going to choose, first I choose upper bound and then I choose lower bound and it'll actually put them in the correct order. So these are my bounds and then they'll go in here, but I need 4 decimal places. Okay, so I'm going to just say round. Let me copy paste the lower bound and 4. Okay, so that'll go here. Now the upper bound, same thing. Let's go to round. It complains because I didn't finish it. Okay, so let's just take this number right here, 4. Okay, so that's going to be my upper limit. We enter that without a space, so it doesn't allow us to put the space. And just make sure that you put it correctly, which I did not. Okay, now I have it. Okay, the last thing is to compute the margin of error. And well, that's the previous before last because we also have to interpret. Okay, so let's do the margin of error. So we press on the /, which is the same key as your question mark. And then we're going to do upper minus lower. So I'm just going to select the whole thing. Subtract. Let me just see if I can make this larger. So this guy right here. copy paste that here. And of course you can copy paste the actual numbers, but just remember that it's upper minus lower, not the other way around, because margin of error is always a positive number. Okay, and then we need to round this to 4 decimal places. So let's just do that. And that will be 0.0786. Margin of error for proportion is always going to be a small number because proportion is a number between 0 and 1. So you're looking for numbers such as 0.01, 0.02, up to maybe 0.1. But if it's larger than that, that study should be completely discarded because you really want a good interval. This is not that great. So I would recommend, because the margin of error, I would say in the ballpark of 2 to 3%, 4% maybe, but 7.9, that's not great. Okay, so now in terms of the interpretation, we're gonna say we are, of course, 94% confident that, okay, so here the favorite mistake of all people, you are estimating the proportion of all adults, which means this is population proportion. Okay, and we're gonna put the numbers. Now it says 2 decimal places and we rounded to 4, so we're gonna have to round again, but I'm just gonna round in my head. So that would be 0.2 and this one would be 0.36, right? And so let's compute that.